So good afternoon, everyone. So now come to our second workshop for the IGADDMAT. So in the first workshop, we only cover the, still remember what we cover? What we cover? Quadratic? No, that one is math, right? Logarithm and exponential function, right? Okay, so now we come to this one, solving the trigonometric equations. So I will show you some of the common questions and show the techniques on answer those questions. Okay, let's look at this one first. This is a simple trigonometric equation. This is the most simplest one. Okay, so how are you going to solve this? If you cannot solve this, then you cannot solve for other trigonometric equation. Okay, so these are the simple trigonometric equation. So how do you know that this is a simple one? You see that on the left hand side, there's only one trigo function. And then on the right hand side, it's only ratio. So this is what we call the simple trigo equation. And then next step is to find out the basic angle. And then when you find out the basic angle, make sure you take the inverse trigo of the positive ratio. Because sometimes the ratio can be negative, but when you find the basic angle, you always take away the negative. So take the inverse trigo of the positive ratio. Next is you sketch a diagram for the Cartesian plane. And then determine the angles in which quadrant. This one you know, right? It's called what we call add sugar to coffee, that one. Okay, you need to decide this angle is in which quadrant. And then draw a straight line from origin in the chosen quadrants. And then do what? Draw a straight line from the origin in the chosen quadrant. Okay, and then next, label the basic angle in the chosen quadrant. So all of you know, right? The basic angle is in between the horizontal axis and the straight line from the origin, right? Okay, always remember between the horizontal axis and with the straight line. The next one, label the desired angles from the positive axis in the chosen quadrants. Now you label the desired angles. The angles they want to find out, label it in the chosen quadrant. And then if the desired angle in the first quadrant, what do? Actually, the angle that they want to find out is actually the basic angle, if in the first quadrant. If in the second quadrant, you just take 180 minus basic angle. If in the third quadrant, just take 180 plus basic angle. If in the fourth quadrant, then you take 360 minus the basic angle. All right. And then don't forget to check the solutions are within the range. This is very important. You have to always check the range. All right, let's see this question. Have the interval of x. This interval of x is very important because it will restrict the solutions. If the interval is not given, that means our solution can be up to infinity. So with this interval, we have limited number of solutions. Okay, now this is what we call simple trigonometric equation, right? Simple trigo equation. We have a trigo function on the left side, and on the right side, it's just a ratio. Then what should we do here? Look at the flow chart just now. Our first step is always find the basic angle. Okay, how do we find the basic angle? Okay, here's a symbol for basic angle, alpha. And then take the inverse of this trigo function, inverse sine. And you see here, the ratio is negative. As I said, if you want to find a basic angle, you always remove the negative side. You don't want a negative sign. Just take the inverse sine of half. So what you get is, okay, this angle is in degree here. So make sure calculator in degree mode, not in radian. All right, you know, we have two types of angles, in degree and in radian. So make sure you change your calculator to degree first. And then take the inverse sine of 0.5. You get 30 degrees. So now you found this is 30 degrees. Okay, let's go to the next step. Sketch a diagram for Cartesian plane. So now we sketch a Cartesian plane here. And how do we label this? Okay, determine the angles in which quadrant. You need to have A, S, TC, right? How you memorize this? I always teach you is add sugar to coffee, right? All the first letters of the words, okay, put in this quadrant. So then you look at the ratio here. We have negative. So you want the sign to be negative. So which quadrant will have the negative sign? Of course, not the first quadrant, right? First quadrant all are positive. So negative sign will be the third quadrant and also the fourth quadrant. Okay, second quadrant sign is positive, the rest is negative. So we want this one, sign negative here. So what's the next step after that? Draw a straight line from the origin in the chosen quadrant. So we have chosen third and the fourth quadrant. So I draw the straight line, right? I draw the straight line from the origin like this. And then we label the basic angle. Okay, basic angle, as I said, basic angle is in between the horizontal axis with the straight line. This one. So these two are the basic angles. And then the next step will be what? Label the desired angles from the positive x-axis in the chosen quadrants. Okay, now we want to find out the angle. Okay, when we want to find out the angle, we always measure the angle from the positive x-axis. Okay, for a positive x-axis, you turn it clockwise or anti-clockwise? Anti-clockwise, always anti-clockwise. Okay, turn it until you meet this line in the third quadrant. And then we can have another one, right? Another one at the fourth quadrant. So we have these two angles. So now, how do you find out the angle in the third quadrant? Let's look at this one. If in the third quadrant, you just take 180 plus the base angle. So now you have your first answer. 180 plus the base angle 30. So you have 210. How about the next one? Next one in the fourth quadrant, 360 minus the basic angle. So we can have another answer here, 360 minus the basic angle. And now we have 330. Okay, so we have two answers. Of course, you need to check whether the answer within the range or not. Right? It's from more than or equal to 0 until less than or equal to 360 degrees, right? So we have these two solutions within the interval of x. All right. Okay, these are the two answers. Okay, now we go to question B. So question B, we have cos x equals to 102. This one, the angle in radian. Okay, our first step, find out the basic angle. Okay, take the inverse cos of 112. Let's give it what? Be careful, this one must be in radian, in terms of pi, not degree anymore. It will be pi over 3. Next step, we go to draw the Cartesian plane. Again, label it, add sugar to coffee. And then we want to get a positive ratio, right, of cos, positive ratio of cos. So which quadrant here will have the positive cos? Of course, in the first quadrant and also the fourth quadrant. Okay, then the next step, label the basic angle. So where are the basic angles? In between the horizontal axis and the straight line. So this one and this one. So now we want to find out the angle X. As you can see, our angle in the first quadrant, right? You just take the basic angle, same as basic angle. And then the second one will be in the fourth quadrant. So you know that the angle in the fourth quadrant is 360 minus the basic angle. Okay, can I use 360? Cannot, right? Because it is in degree, yeah? So you should use 2 pi minus pi over 3. So what you get? 2 minus 1 over 3. Pi over 3. So now we have two answers. X equals to pi over 3 and 5 over 3 pi. Okay, now the last one, tangent. For the x more than or equal to 0 and less than or equals to 2 pi. Again, the angles in radian. Our first step, always find out the basic angle. Take the inverse tangent of square root 3 over 3. So inverse tangent of square root 3 over 3, we have pi over 6. Okay. Is it in degree? Okay. It's okay. Okay. And then we draw the Cartesian plane, label the quadrants, add sugar to coffee. And then look at the ratio here, it's positive, right? The positive tangent here. So we'll be in the third quadrant and also the first quadrant. So basic angle in between the horizontal axis and the straight line. Here. These two. Now you find out that X is actually the basic angle. Okay, the first angle in the first quadrant. 506. How about the next one? In the third quadrant, we should take 180 plus another basic angle, right? So 180 is pi plus pi over 6. One plus 106. So 7 pi over 6. All right, so these two are the answers. So now you know how to solve the simple trigonometric equation. This is the simplest one. If you cannot solve this, again, you cannot solve the rest of the question already. All right, let's move on to this one. Okay. So what's so special about this equation here? You see the bracket? I mean, the things inside the bracket is no longer x, but we have ax plus b. We have coefficient of x and a constant. So for this kind of equation, you need to do some extra step. Okay, you need to find out the interval of ax plus b, start from what angle and end at what angle. So this is very important. Normally, the question only gives you the interval of x, not giving you the interval of ax plus b. So you still have to find out the interval of ax plus b first. And then label the angles on the axis according to the interval of ax plus b. Then the way we label the axis also will be different. I mean the angles on the axis will be different. And then draw a straight line from the origin in the chosen quadrant. This will be the same step as what we did just now. and then label the basic angle. Okay, so the rest will be the same. Okay, so we just need to do some extra step at the beginning. So the rest will be the same. This one you have to check for the solution within the interval. Okay, let's go to this question. So here we have cos. Okay, object plus pi over 6. All right, and then equals to negative half. For two pi. All right. So now, our first step, look at our flow chart, is to not to find out basic angle first, but to do what? Find out the interval of ax plus b first. Okay, you have the interval of z here, but you don't have the interval of this one, z plus pi over 6. You need to find out this interval first. So the way to do it is, look at it, okay, it's plus pi over 6, right? So you just need to add pi over 6 for each side here. So the left side here, 0 plus pi over 6, the middle one, z plus pi over 6, and the right one, 2 pi plus pi over 6. And now you have this one. 2 pi plus pi over 6, 2 plus 1 over 6. 13 over 6. All right, so after we get this interval, we can proceed to label the angles on the axis according to interval. Now we draw the diagram. Okay, look at this carefully. We start from pi over 6. Okay, sometimes it could be negative. This one sometimes it could be negative. If negative, then you have a negative angle. Okay, but this is still positive. Okay, the way you label the axis here is still 0. And then here will be what? 0.5 pi. Okay, I always like to express this in decimal so that I know the size of this value. You can also write it as pi over 2, doesn't matter, or half pi also can. Okay, 0.5 will be easy for me to know the size. So 0.5, and then this is pi, and this is 1.5. Okay, 13 over 6 is, around what value here? 13 over 6. 13 over 6 is 2.167. So always try to change the fraction into decimal first, so that you know the size of this value is around 2.167 pi. That means it's more than 2 rounds already, right? 2 pi is 1 round, so 2.167 is more than 1 round already. Okay, so now we proceed to the next one is, so now we only decide the angle will be in which quadrant here. Okay, it will be one negative cos, right? Negative cos. Which quadrant have negative cos? Second and the third one. All right. And then label the basic angle. And then our first angle in the second quadrant, this one. And then the second angle is in the third quadrant. So now you can find out z plus pi over 6, not yet z. Okay, so far we only find out z plus pi over 6 first. Not yet z. This is for looking the z plus pi over 6. So the first one is, okay, the angle in the second quadrant means you take the pi minus the basic angle. Okay, you still haven't found the basic angle yet, right? Have to get the basic angle first. All right. So get the basic angle first. No need negative, all right? So it's pi over 3. And then now you can find out the z plus pi over 6 is pi minus pi over 3. That will give you 2 over 3 pi. And then the next one, in the third quadrant, you take pi plus pi over 3. And this gives you 1 plus 1 over 3, 4 over 3, 1 and 1/3. All right. Or you can express this as improper fraction also can, doesn't matter. Okay. This one I just want to know the size only. It's around 1 point something. Okay, after that, is this? We have find out all the solution within the range. Here, 2 point something. No, we don't have angle at the in the first quadrant. So these will be the only two answers for z plus pi over 6. But do remember that we are looking for z, not z plus pi over 6. So you have to move this pi over 6 to the right-hand side. So we take 2 over 3 pi minus pi over 6. Another one, 4 over 3, right? Okay, 4 over 3 pi minus pi over 6. Now only you can get the final answer. 2 over 3 minus 1 over 6, half pi. Another one, 4 over 3 minus 1 over 6, 7 pi over 6. Okay, let's look at the next questions. Okay, this is the first one, correct? Should be pi over 2. Pi 2 over 3 over 3 minus pi over 6. Let me check. Cos pi over 2 plus pi over 6. All right, this would be correct. The answer in the slide got a mistake there. Okay, so half pi and 7 pi over 6 is correct. Now we go to the second question. You have 2 sine, this one. 2 sine, and then z plus pi over 3 equals to -1. And 1 over z from 0 until 2 pi again. So you need to rearrange this equation to make it become a simple trigo equation. Now it's not simple trigo equation because you have 2 in front of sine. Okay, you have to remove the 2 first. So remove. You should do the division, right? To remove 2, you divide both sides by 2. And now this is what we call the simple trigo equation. And next step, you can find out the basic angle first. Take the inverse sine, and then take away the negative. So what is this? Pi over 6. All right, then we draw the, before we draw, you have to find out the interval of this one, right? So we want z plus pi over 3. That means the interval for this will be from pi over 3 until 2 pi plus pi over 3. All right, this will be what? 2 plus 1 over 3, 7 over 3, 2.33. It is actually 7 over 3 pi. Okay, 2.33 is more than one round already. Okay. Now, again, you know, we start from 0, 0.5 pi, this 1.5 pi. And now I want to decide, okay, this angle is in which quadrant here? Add sugar to coffee. So we want the sign to be positive, negative. We want it to be negative. So it must be in the fourth and the third quadrant. So now, what's the basic angle? These two. These two are the basic angles. Okay, so now we can find out the first angle in the third quadrant, and also second angle in the fourth quadrant. So we are looking for this z plus pi over 3. So this one will be pi plus pi over 6. So 7 over 6 pi. Okay. Still we need a range, right? More than it. Okay, correct. And then the next one, we can have 2 pi minus basic angle pi over 6. So 2 minus 1 over 6 give you 11. 11 over 6 pi. All right. Okay, so far we have two solutions. Can we go further? Cannot, right? Because you know that the upper limit of this z plus pi over 3 is 2.33 pi. If we go further, it will be, next round will be in the, second round will be in the third quadrant. For sure it will be more than this one already. You know it will be more than this one. So these are the only two solutions for z plus pi over 3. So to get a z, you have to minus pi over 3 for these two answers. Okay. Okay, now next one. Okay, so this is another case. So we go to the next level. So far it's just basic. Okay, we go to the next level, you will see a trigonometric equation with squares. If you see the equation with squares, it's still considered easier. Still considered easy with square. Okay, it's easy to tackle this kind of questions if you find out that some functions has a square. Okay, so our first step, check if the equation has the same trigo functions. This is very important. Okay, when you solve trigonometric equation, make sure that the equation has only one functions, the same functions. Okay, so if you didn't see the the equation has the same functions, so what should you do? You should check for the square of the trigo functions. Look for any square in the equation. And then if you see any square, okay, if yes, if you see the square, what you do? You convert the square of the trigo function into another trigo function using identities. The purpose of doing this is you want to make sure the equation has the same trigo functions. So with the square of the trigo function, you can change to another trigo functions. Then you have the equation with the same trigo function. So you go back, okay? Go back to here to check whether it's the same or not. Now, if it's the same, then you can proceed to the next step already. Next step, you also have to check, still got any square or not. So there's a difference. Here, when you check the square of the trigo function, the equation already has the same function. Here, we don't have any same function here, that's why you need to convert. After you convert to have the same function, then you still have to check whether there's any square of the trigo function. Okay, if yes, then we proceed. We can do the substitution for the trigo function and transform into a quadratic equation. So that's why you see this topic also relates has this quadratic equation. So you need to master how to solve this quadratic equation. And then you proceed, remove the denominators by multiplying the equation by the denominators. This is how you simplify the denominators. And solve the quadratic equation. So let's see, okay, for this one, if you don't see any square of the trigo function, what you do? Later I will let you see. For this case, this is a special case, if you don't see any square. So let's go back to this solve quadratic equation. So after you solve the quadratic equation, you go back to substitution, and then you solve the simple trigo equation. This is what we learned just now, simple trigo equation. That's why you need to know how to solve the simple trigo equation. Then only you can solve for the rest of these questions. Then check the solution within the range. All right, look at this question. All right, you see, this is something special about this equation, that the interval is not from more than 0 until less than 360, but it's less than 180. Okay, so what is our first step? Let's go to the flow chart. So our first step, check if the equation has the same trigo function or not. When you see this equation, it has a function of what? Tangent, right? And also sine. So cosine is come from sine. So this equation has two different trigo functions. Okay, so this equation has two different trigo functions. So it's no, right? So what do you do? Check if any square of the trigo functions. Yes, we do have the square here. So what we do with this square? We can convert the square of trigo function into another trigo function using identity. Okay, so we need to change this one using the identity. So I check the identity here. Okay, so the identity will be, we have three trigo identities. We have sine, okay, sine square plus the cos square. We have 1, and then secant square x plus secant square x equals to 1 plus tangent square x, and then the cosine square x equals to 1 plus cotangent square x. All right, so these three are the identities of trigonometry. So now we want to change this one to another function so that I have the same function with this. So look at this one. We have cot square here. So you know that we can change the cot square to cosec square minus 1. So we change this one to cosec square minus 1. And then minus 5 times the cosec. And then minus 1 equals to 0. Okay, so after you change this one, what you should do for the next step, you go back to check again. Does it have the same trigo function now? Yes, they do have the same trigo function. Okay, These two are the same. Then you can proceed. Check if any square of the trigo function. Yes, we do have square also here. Right? We do have the square also. Then what we do? Do the substitution. Okay, you can do the substitution. So let's do the substitution. You can let u equals to cosec square x. Sorry, cosec x. Later, the u square will be the cosec square x. Okay, so then now this one you can transform into quadratic equation. So this one is u square, and this is -1. -5 u minus 1 equals to 0. And then you can simplify this. Become 2u squared minus 2 minus 5u minus 1 equals to 0. So rearrange this one, you have 2u squared minus 5u minus 3 equals to 0. So now we have this quadratic equation in general form. Can we solve this? Can it be factorized? Now you know, right, how to solve this quadratic equation. Yes, it can be factorized. The first one is 2u plus 1. And the next one is u minus 3 equals to 0. All right, now you can find out the u already. So u equals to minus 102 or 3. Now do remember that we are not looking for the u only. We are looking for x. To solve this equation, you want to solve for x. So you go back to the substitution. That's why in my flow chart, you see. All right, in my flow chart, after you solve the quadratic equation, okay, after you solve it, go back to the substitution. Go back to the substitution. So you have cosec x equals to -half or 3. And then from here, how do you solve this? You can convert this, the reciprocal function here, to sine, right? 1 over sine x equals to -half or 3. If you rearrange this, you will have sine x equals to -2 or 8, hold on. Let me check again. There's a problem here. Because we know that sine x cannot be less than 81. And this is 3. Be weird. Yeah, let me check again. 1 over sine cosec. Anyone find a mistake? Two minus, okay, here is a mistake, is it? -5. Here is a mistake, I think. Let me try again now. 3 There's a problem here. Or, okay, sine x equals to 3. These two are not possible. I'm not sure where is the mistake here. There's something wrong with the questions. maybe we should do another way around. You try to convert this one first to 1 over sine square, and check whether it can get the answer or not. Okay, let's try from here. So after you convert this, you change this one to 1 over sine square x minus 1. And then minus 1 over sine x minus 1. Maybe this will make difference. Okay, then from here, you can times sine square to remove the denominator. So when you times sine square, what happened? 2 minus 2 sine square. Okay, let me check again. Minus 5 sine x minus sine square x. Okay, so far so good. Let me try again. Yeah, so now you have minus 3 sine square x, and then minus 5 sine x, and plus 2. And now you have 3 sine square x plus 5 sine x minus 2 equal to 0. Now let's see. This one, sine x, 2, okay, 1. So minus, and it is plus. Okay, so this is how to do the factorization. Of course, you can do the substitution here. You can let the u equal to sine x, no problem. And then you go back to the substitution. After you solve for the u, you go back to the substitution. Like this one, I skip the substitution. I should always solve for the sine x. Now I think I can get it. Now sine x equals to 1 over 3. Or sine x equals to -2. Okay, so as you can see, now we have a solution for this, and we don't have solution for this. So what happened just now? Why we cannot solve? Just now we assume sine cos square x equal to u. This one I have to figure out. I have to find out why it's not possible. So always have to change the reciprocal function to the original function first. Okay, then simplify the equation, remove the denominators, then only you solve the quadratic equation. So this one is not possible. No solution. You know that the minimum value of sine x is -1 only. Cannot be -2. So now only left is. So again, you can find out basic angle. Inverse sine of 1 over 3. So what you get? Okay, this one in angles. Okay. In degree. 19.47. All right, so this is the basic angle. Add sugar to coffee. So we want positive sign, it will be in the first and the second. So the second one, you take 180 minus the basic angle. So another one is just 180 minus 19.47. So now you have these two answers, 19.47, 160.5. That means 19.5, 160.5. Now we get the answer. All right. So let's move on to, I think I can skip to the next one. Okay, this is V out square. Okay, when you come to the equation that V out square, then you might have some problem. Okay, a bit challenging. If the equation doesn't have any square, that means you cannot use the identity anymore, right? Because you want to use the identity, you must have the square. So here are the guidelines. If you don't see the square, you look for any the reciprocal functions, or if you see tangent, you convert to sine over cos. You see cotangent, you convert to cos over sine. You see second, okay, then you make it to 1 over cos. Cosecant, 1 over sine. So these are the guidelines if you don't see any square. And then try to remove the denominators by multiplying the equation by the denominators. Okay, somehow in this step, then you will find out square because you times the denominators. Somehow you will have the square. Then you can check for any square or trigo functions. And then you can apply the trigo identities. But sometimes you still cannot find out any square. Then you go for this one, check for any common factors and figure out the common factor. These are the guidelines also. And then number 5, if only sine x and cos x are found, then you should change this one to tangent x. Just solve for the tangent x. All right. So let's see these 3 questions. All right, this is from 0 to 90 only. Okay. So now, any square here? No, we don't find any square, and they don't have the same trigo function here. We have cos, we have tangent, we have sine. These three trigo functions here. Okay, so first of all, you change what? The reciprocal function to the original one. Okay, so cos theta, you can change this cot to 1 over tangent. And then plus sine. Okay, and then what we do next? You try to remove the denominator here, right? Just need to multiply this equation by tangent theta. So what you get will be cos theta plus tangent theta sine theta equals to 4 tangent theta. Okay, what we can do from here? Can we simplify this one? Sine over cos. Sine over cos. Okay, let me check again. So normally we change for the tangent, make it to sine over cos first. This one also sine over cos. And then now what we can do, again, you see the denominator, right? So what you do, you times the denominator, right? You can remove the denominator by multiplying the denominator. So we have cos squared. And now we don't have any cos here, it will be sine square. Right, and then equals to 4 sine theta. Okay, so what's the good? So what do you see here? Hey, now you see square. Right, somehow now we see square. So we can go back to our identity. Right, let me rewrite all this. Okay, and then the last one, never mind. Okay, let's look at this one. The first one, you see, sine square plus cos square is 1. That means it is actually 1. 1 equal to 4 sine theta. And now you can rearrange this one to make it become simple trigo function or simple trigo equation. Now from here, you know how to solve this. Okay, so first of all, find out the basic angle. $14.48, and then the next one. You want in the first and second quadrant, right? Add sugar to coffee. So the second angle in the second quadrant. So you take 180 minus 14.48. 165. So this is 14.5. Another one is 165.5. But what? You have to check whether the answer within the range or not. Okay. Is it within the range? We want to have the data until less than or equal to 90. So this one will be rejected. Okay, we don't want the 165.5. We only want 14.5. Okay, understand? Okay, only 14.5. So now we go to the next part. So this one, sine x minus 2 tangent x equals to 0. Again, you didn't see any square. So what should you do? When you see tangent, we always want to change the tangent. Okay, when you see tangent, we always want to change the tangent to sine x over cos. And then you see denominator. You see denominator times the denominator. So you have sine x cos x minus 2 sine x equals to 0. Okay, so what's good? And from here, what do you see? You still didn't see any square here. So what do we do? There's no square. But you do have common factor. You do have common factor. Even though there's no square, you have the common factor here. That means you can factorize out the sine x. Then we have cos x minus 2 inside the bracket. Okay, so now, how do you solve this equation? There are two factors here. How we make this left-hand side become 0? Either one of these factors must be equal to 0. Either sine x equal to 0 or cos x minus 2 equals to 0. Get here? what will be this value? And check for the range. Oh, it didn't state the range here. So assume that it's until okay, 360 here. So how do you get the x value or sine x equal to 0? So this one, you can check the graph. Okay, this one you don't need to use the Cartesian plane, the x should go to copy. Okay, you don't need to apply that, especially when you see the trigo function equals to 0, 1, or -1. You just draw the graph. Okay. And then check for it. Sine x equal to 0 means what? The x-intercepts, right? All this. So now you know. The x is 0, 180, 360. Okay, if let's say sine x equals to 1, then the angle should be what? Is it 1 is here? 1 is here. 1 is here. So the angle must be 90. Right, 1. If -1, then this is 270. So when you see the sine x equals to 0, 1, or -1, okay, use the graph to find out the angle. So how about this one? Cos x equals to 2. Well, for this one, you don't have any solution, right? Okay, you know that the maximum value for cos x is 1. Cannot be more than 1, so no solution. All right. Okay, why I write 180? Maybe the range restricted to 180, or maybe like this. Okay, maybe this is the interval. I forgot to write the interval. So for this case, okay, 0 is not allowed, right? If I write x more than 0, 0 is not allowed. And then 360 is not allowed, right? Because the maximum is 180. Not allowed. So only 180. Now the last one, C. Pi cos 2y minus 4 sine 2y equals to 0, and y from more than 0 until less than 180. Okay. So what do you see here? You don't see any square, you don't see any tangent, you don't see any reciprocal function. So you cannot change anything. But you do see that cos and sine only. You see this equation only has cos and sine, then you change these two to tangent. So how do you do that? Okay, you can move this one, -4 sine 2y, to the right-hand side. All right, and then you try to divide both sides by cos. I want to change it to tangent, right? This is how I change to tangent, right? Divide this equation by cos. Okay, and what you see here? Sine over cos is tangent. So now we convert to tangent. Now tangent 2y equals to 5/4. Now we have the simple trigo equation. All right, from two different trigo functions now become the same trigo function. So now how do you solve this? Take the inverse tangent, find basic angle. Okay, 51.6 something. Okay, then cut the sibling. All right, this one. You want to have positive tangent first and the third. But we can ignore the third one. Why? Because of the range. Is it? Can be. No, right? You see, what we're going to get here is 2y. It's not y. Do remember, if you have multiple angle here, you have to find out the interval of this multiple angle. So now you know 2y is actually from more than 0 until less than 360. Be careful here because it is 2y, it's not y. You have to find out the interval of 2y. So interval of 2y is from more than 0 until less than 360. So still, I mean, you still take the first and the third quadrant. Okay, still within 360 here. So basic angle, okay, these two are the basic angle. So now you have the first value for 2y is the basic angle. The second one will be the third quadrant, 180 plus 51.34. Okay, but still not finished yet because you have to get a y. So divide this value by 2. $25.67, another one. 231.34 over 2. 115.67, right? That means 7. Here is 7. Okay, always remember, if the angle in degree, you must give 1 decimal place for the answer. All right, correct. Okay, I think we finished. Then we go to the next one about function. Okay, we still have 10 more minutes. We can utilize the time. Okay, the last 10 minutes. Okay, so problems, I mean functions. So here, the first one, okay, this is the most common question in function. Always ask you to find out the range. Okay, if I to check the function, you notice that the first question, the very first question, they ask you about the range. Okay, range of the function. So what should we do? You need to sketch a graph. Okay, there's no marks for sketching the graph, but you still have to sketch a graph, unless you have a very good imagination. Okay, so sketch a graph first, and then check the domain. That means where the x value start and where the x value ends. This is very important. This is called endpoints. You need to check the endpoints, where it starts, where it ends. And then determine the endpoint. This is what we call endpoints, correspond to the domain. And then determine the minimum and maximum of the graph. So after you have the graph, you know where is the minimum, where is the maximum. From the endpoints, you will know. So from that, you can find out the range. So range means from the minimum to the maximum. That's the range of the function. Okay. So now let's see this one. Okay, how do we solve this? Find out the range. Is it we have the next section, the next workshop at 2:30? No. If not, then I need to end earlier. No. Okay. So now this one, our first step is what? Okay, I write down the question first. It's getting no more ink. All right. So look at the guideline, our flow chart, sketch a graph. Okay, how do you sketch this kind of graph? X squared plus 4. So first of all, you need to know how to sketch a very simple quadratic curve. The simplest quadratic curve is y equals x squared, right? This is the simplest one. So how do you draw this? It's actually the U shape. The U shape that only touches the origin at one point, right? Like this, a U shape. So this is for y equals to x squared, okay? Origin. But what we want here is what? X squared plus 4. If you have the constant at the back, means what? You need to shift the graph upwards by how many units? 4 units. So shift the graph upwards by 4 units. So now the minimum point here is no longer origin. It will be at 4. Right? The minimum point will also shifted up, right, by 4 units. Okay, this will be the function f. It's very important to have a sketch first. And then, second step, check the domain. Where it starts, where it ends. It starts from more than 0, right? X more than or equal to 0. So we don't want the left part here. Okay, we don't want left part. And the rest of this also we don't want. This one we don't want. So this is the end point, the starting point. So I draw a dot here. It's called closed circle. It's different from open circle. If closed circle means this value is included, because here you have equal sign. 0 is included. You have to draw a closed circle. And then until where? Until nowhere, right? Until up to infinity. Okay, so then next step, identify the endpoints, right? Find out the endpoints. And then determine the minimum and the maximum of the graph. So now you can check the graph. Where is the minimum point here? The maximum minimum value. Here is 4, right? Here is minimum. Maximum, we don't have any maximum value. You want to say maximum value, it is up to infinity, right? So how do you write the range now? When you write the range, you always write in y or f of x. Don't write x. If you write x more than 4, it'll be wrong. Because this is range, it must be referred to y or f of x. This one, be careful. So your answer must be in y more than 4, that's all. You don't need to write less than something because we don't have any less than something. Okay, we don't have maximum value here. Just write more than the minimum. Do we have equal sign? Yes, sir. We do have equal sign. Okay, what's the time now? Okay, 3 more minutes. Can we finish? Okay. Okay, let's see this one, the last one. More than 1. You see here, now the domain change. Domain change right here. Here. So we start from here. This part, we don't want anymore. So erase it. Then what is this point, end point here? What happened when x is 1? We have 5. This one is 1, 5. So what's the range now? It's no longer start from 4. It start from 5, right? The minimum value here is 5. So this case, f of x more than or equals to 5. Understand? So it's very important to check where the x values start and where the x values end. Where you will decide the range also. Okay, so that's the end of this workshop. So the rest I will continue in the next class. So see you. Bye.